Okay, in the previous series of videos that I've posted, I've looked at most of the maps that you'll find in this file, but I'm going to just take this opportunity to look at these three maps here. It's almost certain that if you're looking at files you will spot maps that look like these, and you may wonder what they are, so I thought I might as well, while I'm here, just go through what these appear to be. Now, they've been found by Winols, and they surprisingly often are found by Winols, so you may well find these highlighted in various files. Now what I'm going to do then is I'll click on that one. There we go. And at the same time I'll click on that one, and there's a reason for this. And that reason being they look very, very similar. Now let's have a look and see what we've got. If you've been looking at the previous few videos, you will spot that a mile off, especially 2731, because you will be thinking to yourself, 2731, that's probably 273.1 in Kelvin, which is 0 degrees Celsius, so there's a very good chance that's temperature. So what I'm going to put in there is temperature. I'll just put a C there, save mucking about with degree signs. And if that's the case, then I'm going to want 0.1 there, and I'm going to want minus 273.1 over there. And what shall I have a precision of? We'll have a precision of 1. Okay. We've got some quite high temperatures. Let's go and look at this one and see if that's the same. So we'll assume that that's temperature. So just like before, I'll put a C in that one. I'll assume that that one's 0.1, and I'll put minus 273.1 in that one. I'll give it a precision of 1, and I'll say OK. Right, well, they've both got the same scale by looks things, haven't they? They've both got the same axes there. Now, Winols has picked up revs per minute here, but obviously the revs per minute are looking particularly daft at the moment, so yeah, and it's put in 0.01, so if it is revs, that's obviously not correct, so we'll put 1 in there. That may or may not be a sensible revs per minute. We'll see about that in a moment. Let's go and look at this one. So again, we'll put a 1 in there, and we'll say OK. Now the thing is what are these two maps doing, or what are they involved in? Well, we've got something that varies with temperature and possibly with revs per minute, but very low revs per minute, as we can see. 1600 at the maximum there, 1600 at the maximum, and in fact it's not 1600 maximum, is it? Because at 1550 we've got figures, and at 16 we haven't, so at 1600 it's stopped, whatever it is. So what works in the car varies with temperature, but only works at low revs. You may have already guessed. These are probably the starting maps for the engine. So in other words, we're trying to turn the engine over, so we're turning the engine over on the starter motor, and then maybe it catches, so the revs can change or they vary in there, and we need it to start. Now to get it to start, presumably we need to inject some fuel, and maybe we need to change the injection with temperature, so maybe we can inject less up here with a warm engine, and we need to inject more down here with a cold engine. So let's take a guess that that is actually injection quantity, which means that we've been using milligrams per stroke for that, so we'll guess that it's milligrams per stroke. And then we'll put in here 0.1, and we'll go with 1 precision. Oh, put in the wrong number there, 0.01. Okay, so there we are. So it looks like we're injecting quite a lot of fuel here, but then the engine is freezing cold, and a lot less fuel over here, but there again the engine is hot. So maybe that's my starting map to get the whole thing started. Now I'm going to guess that this is a base starting map of some sort, so like just a basic version of the starting map, and so I'm going to guess that this is exactly the same, but it isn't identical, is it? So it's a sort of exactly the same. So what I'm going to do is I'm going to assume that it's some kind of starting map. So I'm going to assume that that's injection quantity. So I'm going to assume that it's measured in milligrams per stroke. So I will need that to be 0.01, and I will want a precision of, let's say, 2. I'll OK that for now. Right, let's look at these side by side. They're virtually the same, aren't they? But they do start to change. Something changes over here. Now, these files do sometimes have two starting maps. They have a basic starting map, which that one could well be there. And then they have another map which is dependent on the output voltage of the alternator. They often call it a terminal 50 voltage. So what I'm going to guess is that this is the main starting map, and this is the starting map that is variously slightly different because of the alternator voltage. Now, if it is, then maybe this one just gives a little bit more oomph on occasions, but then we don't know which one's being used. The chances are this one's being used and maybe not this one, or both, or whatever. So it's not easy to tell. So what I'm going to do though is I'm going to go back and I'm going to call that one then a start map. Well, I could call it an engine start map, couldn't I? So I'll call that the engine start map, and let's call it basic. Engine start map basic, and hope that we've got that one as correct as the basic map. And then we're going to call this one again engine start map. And I'm not 100% sure, but I think this one probably is to do with alternator voltage. So what I'm going to do is I'm just going to put in brackets alternator and a question mark to remind myself that that's what I thought that one was probably for. So I'm going to assume that that one's the alternator. This is not a completely blind assumption, because obviously I've looked at various maps over the years and there's a fairly good chance that that's what we're looking at. Right, okay, I'll get rid of those two because there's another one, isn't there, right next door that looks very similar. So what I'm going to do is I'm going to pull that one up as well and have a look. It thinks we've got temperatures, minus 24, minus 10, 0, 50. I mean, they look like they could be reasonable temperatures, so I'll take a guess that's correct. We've got revs per minute, which looks completely daft. We'll go with the idea of being revs per minute, but if that's revs per minute, we'll change that to 1. And then we've got these in here. So what we'll do is we'll assume that they are what they were last time. So we'll assume that that is injection quantity. We'll assume that it's measured in milligrams per stroke. And so we will take a guess that that's 0.01, and we'll have 1 decimal point for the precision. Right, now let's have a look at what we've got. Right, now again, we can't be 100% sure on this, but again, from looking at posts on forums and information on the internet, I'm fairly convinced that this is what's known as a full load increase map. So that's what I think that one is. It's a full load increase. And if I just close that down out of the way, or full load increase map, and I just get it out of the way. And it looks like it's something to do with helping make sure there's a bit more fuel when it's cold, doesn't it? Because it operates quite a lot down here, minus 24, minus 10, 0. And then at 15 degrees it's almost not operating, it's a little bit. And by 22.5 degrees there, it's stopped. It's on 0. So maybe that's exactly what that one is. That's a full load increase. So what we've got then is we've got 2 starting maps, and then we've got a full load increase map. Now that is pretty much everything covered in this file. There's a few other odd maps that we could look at, and I'll wonder about posting something on those at another date, but I'm going to assume that I've pretty much covered everything that people will want to know in this little series of videos. So if you're going to have a go at looking at a file using Winols, well, good luck, and I hope this helps.